वीडियो करी है।
गुड मॉर्निंग स्टूडेंट्स, आवाज येते का? Yes, anyone tell me? आवाज येते का? हितेश? Write in chat box. Yes. So today we are going to start the new chapter of physical chemistry. The name of the chapter is Ionic Equilibria. It is having 4 marks weightage and with option it is 6 marks. So this is a newly introduced chapter in this new syllabus. In the old syllabus, this chapter was not there. Actually, this chapter was there in 2008 to 2012 syllabus. In 2012 syllabus, it is reduced. But now, as per requirement of NCERT for the competitive exams, again it is introduced in the syllabus, Ionic Equilibria. So first we will discuss what is meant by Ionic Equilibria. Though the chapter is very small chapter, it is only having the 15 pages. But the weightage is more. Weightage is 6 marks weightage. So we can get again out of marks in this chapter. One numerical maybe for 1 mark or 2 mark it will be asked. No any numerical of 3 marks will be asked on this chapter, remember. Small numericals will be asked. So first we will discuss what we have to learn in this chapter. So first, what is mean by ionic equilibrium? This is very important. The equilibrium, this picture is, you can see this picture, equilibrium means equal. So the equilibrium between ions, remember, ions means these ions are positively charged cations and negatively charged anions. These are called as ions. So the equilibrium between ions and unionized molecules. Molecules always these are unionized because they do not get dissociate. So the equilibrium between ions and unionized molecules in the solution, it is called as ionic equilibrium. So in this chapter we have to learn the equilibrium between ions and unionized molecules, remember, in the solution. This is called as ionic equilibrium. So particularly in this chapter, we are going to learn the equilibrium of this H plus and OH minus ions and unionized water molecules. Then the ionization of weak acids and weak base. So further we will discuss what is meant by weak acid, weak base. Then the relations between ions of salt and ions of water. Then last we will discuss this solid salt and its ions in water. This content we have to discuss in this chapter. So this on this introduction part, no any question will be asked for the board exam. Remember this definition also it will be not asked. So forget about this slide. This is only for your understanding purpose. It is given which content it is included in this chapter. So remember ionic equilibrium, it means the equilibrium between ions and ionized molecules. It is so to understand what is mean by ions, what is mean by molecules. Already these concepts are clear. What is mean by molecules, ions concepts are also clear. But electrolyte, I think this concept is also included in 9th standard and 10th standard. But for the 12th standard, there are types of electrolytes are there. Before the types of electrolyte, you must understand what is mean by electrolyte. So electrolyte I will discuss first. The substances which produce ions, remember. Again, ions means positively charged cations and negatively charged anions when they dissolved in water. When any substance which dissolved in water produces ions, it is called as electrolyte, remember. For example, if NaCl, we can see this one diagram I have shown here. This is NaCl salt. We are using in our day-to-day life. This is also called as table salt. When water is taken in a beaker and when it is dissolved, so this is the NaCl crystals which is having Cl minus and Na plus. When they dissolved in water, see these types of ions are produced. Positively charged Na plus we can see here, negatively charged Cl minus. So this is called as electrolytes. Means a substance when it is dissolved in water, they produce ions. The ions may be positively charged and negatively charged. So with this diagram, the concept is clear. What is meant by electrolytes? Opposite to this electrolytes, there are substances which do not produce ions when they dissolve in water. These are called as non-electrolytes. Non-electrolytes, these are the substances, they do not ionize, means they exist as a molecules. They exist as a molecular form. In the aqueous solutions, for example, urea is there, for example, glucose is there. So these are the substances when they dissolve in water, they do not produce ions. But the substances like NaCl, substances like KCl, copper sulfate, when copper sulfate dissolved in water, they produce the Cu2 plus and SO4 2 minus anions and Cu2 plus cations. These are separated. So electrolyte conducts electricity, non-electrolyte do not conduct electricity, because for the conduction of electricity, the anions are required. The negatively charged anions are required. So the substance if do not produces ions, they do not conduct electricity. Hence non-electrolytes. So non-electrolytes, they do not ionize, they do not produce ions. They exist as a molecular form. They do not conduct electricity, remember. So this is for knowledge only. Already you know these concepts. Now I'm coming to the strong electrolytes and weak electrolytes. Electrolytes are again classified in these two parts, two sections. Strong electrolytes, their extent of ionization is more. So depending upon the extent of ionization, the electrolytes are classified as strong and weak electrolytes. So as the name suggests, strong electrolytes, the extent of ionization will be more in water, and weak electrolytes, so the extent of ionization is less. So first we will discuss what is meant by strong electrolytes. The electrolytes, now the concept is clear. Electrolytes means what? Electrolytes means the substances when they dissolved in water, they produce ions. So the electrolytes ionize completely or almost completely are strong electrolytes, remember. So the strong electrolytes, these are the substances when they dissolved in water, completely these are dissociated, means completely the positively charged. For example, if you take the NaCl, NaCl is a strong electrolyte, means NaCl if dissolved in water, completely Na plus and completely Cl minus will be dissociated or separated. For example, strong acids and strong bases. NaOH, it is a strong base. Then HCl, this is a strong acid. We will discuss further what is meant by strong acid and what is meant by strong base, because the theories are there. What is mean by acid, what is mean by base, we will discuss later. So remember, strong electrolyte, they dissociates completely, they ionizes completely. Opposite to this strong electrolytes, I am coming to the weak electrolytes. The electrolytes which dissociate to a smaller extent, see, they do not dissociate completely, but they dissociate means they ionize in a smaller extent in aqueous solution. These are called as weak electrolytes. For example, weak acids, weak bases belongs to this class. Weak electrolytes means completely the dissociation is not completed. Partially they dissociate. Partially means 50% or more than 50% or 80% they will dissociate, but not completely dissociates at like strong electrolytes. For example, I will give the example CH3COOH. CH3COOH, it is the acetic acid. When it is dissolved in water, it is not completely dissociated, it is partly dissociated. So these are the weak electrolytes, dissociates partially in the dilute solutions. So in case of weak electrolytes, the equilibrium is established between ions and non-ionized molecules. Remember, means some of the molecules remains as it is, because they molecules are also called as non-ionized, because they do not dissociate into ions. So in case of weak electrolyte, the equilibrium is exists between ions and unionized molecules, remember. And this is shown with this double arrow. When the double arrow is there, we have to understand this dissociation is not completely, this dissociation is partially, so it is a weak electrolyte. When there is only single arrow, means the dissociation takes place completely, it is a strong electrolyte. So this meaning of double arrow indicates there is equilibrium between ions and unionized molecules or non-ionized molecules, remember. Then I am coming to the degree of dissociation. This definition can be asked for 1 mark. The definition of strong electrolyte can be asked for 1 mark. The definition of weak electrolyte can be asked for 1 mark. So for 1 mark, these questions can be asked. Then I'm coming to this degree of dissociation. This degree of dissociation, it is denoted with symbol alpha, remember. So what is meant by degree of dissociation? See, this according to this equation, we can understand alpha is equal to number of moles dissociated divided by total number of moles. Means this degree of dissociation, it is defined as the fraction of total number of moles of an electrolyte. Fraction of means very, very little amount. Fraction of total number of moles of the electrolyte that dissociates into ions when the equilibrium is attained. Means only the fraction means only the very, very small fraction of total number of moles. So the equation is given, a total number of moles dissociated divided by total number of moles. It is called as alpha. And how to remember the definition means from the total number of moles, whatever the moles dissociated, it is called as alpha. So only small amount of, only fraction of total number of moles of the electrolyte that dissociate into its ions when the equilibrium is established. So from the total number of moles, whatever the number of moles dissociated, it is called as alpha. And the percentage degree of dissociation, it is called as alpha into 100. Alpha into 100, it is called as percent degree of dissociation. And degree of dissociation means number of moles dissociated from total number of moles. So this, by using this formula, we have to solve the numericals also. If C is the molar concentration of the electrolyte, C. If C is the molar concentration of electrolyte, then the equilibrium concentration of the cation or anion is given by alpha into C moles per dm cube. So this, what is mean by this alpha into C? This is the equilibrium concentration of the cation or anion, alpha into C, where C is the molar concentration of the electrolyte. Then I am coming to what is mean by acids and what is mean by bases. These theories are very important for the board examination, because many times in the previous syllabus also this question is asked for many times, what is mean by Arrhenius theory. There are three theories. Before these three theories, in our day-to-day life, we are facing the different acids in our day-to-day life. For example, these acids are given. Acetic acid, it is found in vinegar. Citric acid, it is found in lemons. Then magnesium hydroxide, it is used as antacid. Actually, it is the base. Then ammonia is also the base, which are used in household cleaning products. Then tartaric acid, this is present in tamarind. These are the some acids and some bases we are came across in our day-to-day life. But what is meant by acid and what is meant by base, this is explained by the different scientists. So the different scientists theories are given. First one is Arrhenius theory. These are the theories of acids and bases, remember. So Arrhenius is the name of the scientist who given the definition of what is meant by acid and what is meant by base. So according to the Arrhenius, what is acid? Acid is a substance which contains hydrogen, remember. Means Arrhenius के हिसाब से Arrhenius क्या बोलता है कि those substance which contains hydrogen and gives H plus ions in aqueous solution. Means उनमें hydrogen भी होना चाहिए and they should give H plus ions in aqueous solutions. ऐसे जो substances है उनको बोलना है acid. जैसे Arrhenius का assumption है. And what is meant by base? First, I will explain what is the definition of acid and what is the definition of base. Then I am coming to the examples. So the substance that contains OH group, remember, a substance which contains OH group and produces hydroxide ions. Hydroxide ions means OH minus ions in aqueous solutions. So the definitions are clear. The substance which contains hydrogen and gives H plus ions in aqueous solution, it is called as acid. And the substance which contains OH group, that is hydroxide ions, they produce hydroxide ions in aqueous solutions, it is called as this. Then I am coming to HCl. So this HCl, it already having the hydrogen, and when this HCl it is dissolved in water in aqueous solution, they produces H plus ions. So according to the Arrhenius theory, HCl is a acid because it follows both the conditions which are given by the Arrhenius. It also contains hydrogen and it also produces H plus ions in aqueous solution. Then another example is given here. See, we can see the difference between these two examples. This SCl, it is shown with dissociation with shown with single arrow, and this dissociation of acetic acid, it is shown with double arrow. Means SCl is a strong acid. Completely this H plus and Cl minus will be dissociated. But in case of this acetic acid, as it is shown with the double arrow, means partial dissociation takes place, 100% dissociation do not takes place. That's why the double arrow it is shown, and when it is a double arrow, this is a weak electrolyte, this is a strong electrolyte. So this is a strong acid and this is a weak acid, remember. So strong acid which will be dissociated completely, and weak acid means which do not dissociates completely. This is partially dissociated. It produces CH3CO minus ions and H plus ions. So according to the definition of Arrhenius theory, this CH3COH is also having hydrogen, and when it is dissolved in water or in aqueous solution, it produces H plus ions. So according to the Arrhenius theory, HCl is a strong acid and CH3COH, acetic acid, is a weak acid. So according to the Arrhenius, H plus ions in water, these are bare ions. So this H plus ions combines with H2O, and they can be represented as H3O plus. So this H3O plus is nothing but H plus plus H2O. It is H3O plus, but for a convenient purpose, we represent as H plus. Remember, this is extra knowledge it is given. So according to the Arrhenius, H plus, actually these are the bare ions. They hydrate in aqueous solution, means they combine with H2O. And the hydronium ions means this is a combination of H plus and H2O. Conveniently, we shown like H plus. So H3O plus and H plus, the meaning is same. It is acidic. Now I am coming to the base. According to the Arrhenius theory, the base are the substances which contains OH group, and when they dissolved in water or when they aqueous solution, they produces OH minus ions. So again, the two examples are given. One is strong base and one is weak base. So NaOH, already it contains OH group. When dissolved in water, Na plus and OH minus, these cations and these anions are produced. Completely it is dissociated. Single arrow, this single arrow indicates it is a strong electrolyte, completely dissociate, Na plus separated, OH minus separated. So OH minus is there, so it is a base according to the Arrhenius theory. And this NH4OH, ammonium hydroxide, this is not completely dissociated. It is partially dissociated in water. So the double-headed arrow is shown here. NH4 plus and OH minus ions are prepared, but it is a weak acid, weak base. Sorry, it is a weak base, and also it is a weak electrolyte. Arrhenius theory accounts for the properties of different acids and bases. It is applicable only to the aqueous solutions. Means what is meant by acid and what is meant by base, this will be understand when these substances dissolved in water or when they are in aqueous phase. Then only we can identify these are acids or bases. It does not account for the basicity of NH3. Means Arrhenius theory didn't give the answer why this ammonia is basic and Na2CO3 which do not have OH groups. This NH3, this do not having OH group, this Na2CO3 also, this do not having the OH group, but still these are bases. So another theories are discovered which gives the definition of acids and bases. Acids, according to this Arrhenius, acid is a substance which should contain H plus ion. And what is base? It should contain OH minus ions. But there are these two examples which do not contain OH minus, OH group. but these acts as a base. So another theories are there. The second theory is Bronsted-Lowry theory. Again, Bronsted-Lowry theory, these are the two scientists who discovered this theory, Bronsted-Lowry theory. Bronsted and Lowry, these are the two scientists who discovered this theory. So they also given the definition of acids and bases, what is mean by acid, what is and bases. First we will discuss what is mean by acid. Acid is a substance that donates proton. See, this definition is different from Arrhenius. Bronsted-Lowry, according to the Bronsted and Lowry, acid is a substance that donates proton to another substance. Means acids are called as proton donors and bases are called as they accepts proton acceptors from the another substance. These are called as bases. So acids are proton donors, bases are proton acceptors according to the Bronsted-Lowry theory. So there are some examples are given here. One example is given. HCl, it is a proton donor. So it acts as acid. This ammonia, NH3, which accept proton. So this HCl is acid because it donates proton. This NH3 ammonia, it accepts proton. So it is called as base. HCl, it is acid 1, NH3, it is a base 2. This is a double-headed arrow which it is shown. It is called as conjugate acid-base pair. I am coming to that concept. What is mean by conjugate acid and what is mean by conjugate base. So this HCl, according to this Lowry-Bronsted theory, HCl is acid because it donates proton. NH3 is a base because it accepts proton. This NH4 plus, see this NH4 plus, it is a acid 2. NH4 plus, it is called as acid because this donates proton, and this Cl minus is a base because this can accept proton from another substances. In this above reaction, we can see HCl and NH4 plus. This HCl and NH4 plus, these are called as acids because these are proton donors. This NH4 plus is also proton donor. This HCl is also proton donor. But this NH3 and this Cl minus are proton acceptors, and these are called as bases. This actually acid 1, base 1, base 2, say acid 1, acid 2, base 2, base 1. This is called as conjugate base. So I will explain what is meant by this conjugate acid base pair. Conjugate base means what? It is a base produced when an acid donates a proton. See, conjugate base किसको बोलते हैं? It is a base produced when acid donate protons. It is called as conjugate base of that acid. And opposite to this conjugate base, conjugate acid, it is produced when base accepts a proton. It is called as conjugate acid of that base. It is quite confusing what is meant by conjugate base and conjugate acid. Conjugate base, it is produced when acid donates a proton. And what is conjugate acid? It is produced when base accepts proton. So the definitions are same. Acid donates a proton and base accepts a proton. So conjugate base, when the conjugate base is formed, when conjugate base is produced when acid donates a proton, and conjugate acid is formed when base accepts a proton. So a pair of an acid and base, it is conjugate acid base pair. It is actually the pair of acid and base, only there is a difference of one proton, remember. So conjugate acid base pair, it is differentiating or differing only by one proton. It is called as conjugate acid base pair. This can be asked for the examination for 1 mark or 2 mark. Write a note on conjugate acid base pair. So again, I am coming to this example. HCl, it is a acid because it donates proton. So acid 1 is key conjugate base pair A. This is a acid 1 and this is a base 1. See, this Cl minus acts as a base because this base is produced. This base is produced when acid donates a proton. It is called as a conjugate base of this acid. See, this HCl, when this HCl donates a proton, it is called as acid. And why this is a base? Because from this base, H plus is given. So there is a difference of only a proton. Again, I am coming to this H2 and H3O plus. We can see there is a difference of proton only. One proton is extra here in case of H3O plus, and in case of this H2O, one proton is less. So it is a base and this is acid because conjugate acid, remember, conjugate acid is prepared when base accepts a proton. This base accepts proton from this. So this is a conjugate base and this is a conjugate acid. Remember, so these are the examples of conjugate acid base pair. Make a practice at your home. What is a conjugate acid? What is conjugate base? There is a difference of only one proton. Remember. Then I'm coming to the next theory. This is a Lewis theory of acids and bases. Two theories are completed. One is Arrhenius theory, and second one is Laurie-Bronsted theory, and this is a Lewis theory. According to the Arrhenius theory, what is meant by acid? Which produces H plus ions in aqueous solution. What is base? Which produces OH minus ions in aqueous solution. What is Laurie-Bronsted theory? According to the Laurie-Bronsted theory, acids are proton donors, bases are proton acceptors. This is the Lewis theory, which is related to the electron pairs. So according to this Lewis theory, any species that accepts an electron pair, means acids are electron pair acceptors. These are called as Lewis acids, and bases are the substances which donates electron pair, is called as Lewis base. So again, I'm coming to this example, this NH3 ammonia. This ammonia having the electron pair here. When this electron pair is given, so this is acts as a base. According to the definition, bases are the substances which donates a electron pair, and acids are the substances which accepts the electron pair. So in this example, H plus acts as a acid because it accepts the electron pair, and this ammonia acts as a base because it donates the electron pair, lone pair. When the lone pair is given, when the lone pair is donated, this is called as Lewis acid. In the chapter amines, we also discuss this definition. Amines are always acts as a base, Lewis base, because they donates the electron pair. They donate the electron pair. That's why these are called as Lewis base, and these are acts as the Lewis acids. Another example is given here, BF3. It accepts electron pair. So these are the acids, and ammonia is a base because this lone pair is given. This lone pair is accepted by the acid. So this is an acid and this is a base because lone pair is given base. Lone pair is accepted acid. So remember the definitions. So at a glance, this chart is given to you. What is mean by acid-base theories? Different acid-base theories are given. Arrhenius theory, acid definition is given. Any substances which gives H plus ions, base definition is given. Any substances which releases OH minus ions, Bronsted, which donates H plus. This is a Laurie-Bronsted acid. Laurie-Bronsted acid means these are proton donors, these are proton acceptors, and then Lewis theory. Lewis theory is related to the electron pair. Acids accept electron pair and bases donate electron pair. So at a glance, we can remember the definitions of acids and bases of all the three theories. This is important for examination, very, very important for examination. Arrhenius theory, Bronsted-Lowry theory, Lewis theory. For the 1 mark, the definition of acids and bases are also asked. For the 2 marks, they can ask the question, write note on Arrhenius theory. So we have to write the definition of acids and bases. They can ask the question like, explain acid and base with respect to Lewis theory. Explain acid and base with respect to Laurie-Bronsted theory. So this part is very, very important for the board examination, remember. These theories, acid-base theories, according to the Arrhenius, Laurie-Bronsted and Lewis theory. Then I am coming to the next part, amphoteric nature of water. You know, water acts as amphoteric, means it acts as acid, or also it acts as a base. So water having the ability to act as an acid, also acts as a base, it is called as amphoteric. Amphoteric in nature. Such behavior is known as amphoteric nature of water. Example is given here. H2O plus ammonia aqueous. This is a equilibrium, it is shown. OH minus aqueous, NH4 plus aqueous when it is dissolved in water. See, when this water acts as acid, this equilibrium is shown. And in this equilibrium, this water acts as a base, H2O liquid, HCl, H3O plus, and Cl minus. So H2O acts as an acid towards ammonia, and this H2O acts as a base towards HCl. So H2O acts as an acid towards ammonia, and it's acts as a base towards HCl. Therefore, H2O is an amphoteric in nature. Amphoteric means it can shows the properties of acidity also. It can shows the properties of basicity also. See the equilibrium carefully. In this, when H2O and ammonia, these are mixed together, they H2O acts as an acid. When H2O and HCl, these are mixed together, this H2O acts as a base. So for the examination point of view, they can ask the question, why the water is amphoteric in nature. So we have to show these equilibriums of acid and base equilibrium. Then I am coming to the ionization of acids and bases. Ionization means the formation of, it is also called as dissociation. It is also called as formation of ions. So acids and bases are classified as strong acids and strong bases, weak acids and weak bases on the extent of dissociation. Already this part I explained earlier in the definitions of strong electrolyte and what is a weak electrolyte. So the strong acids and bases almost they completely dissociates in water, remember. Example, this HCl completely dissociates, which gives H plus and Cl minus. NaOH completely dissociates, which gives Na plus and OH minus. So some examples are also given. Strong acids, HCl, HNO3, H2SO4, HBr, HI. Then strong bases are NaOH, KOH. These are completely dissociated in water. Opposite to this, these are the weak bases, weak acid and weak bases, which are partially dissociated. The example of acetic acid, example of ammonium hydroxide, these are the weak acids. Definitions are given. This is HCOH, formic acid, HF, then H2S. These are the example of weak acids. While FeOH thrice, ferric hydroxide, this is